here, come pick both of those up. There's one is a notes page for solving 3x3 systems, and one is a practice assignment. Okay, but before we jump into those, we need to continue where we left off on Wednesday. So on Wednesday, we had this set of notes that was just, it says Unit 3, Systems of Equations. So we need to get this set of notes back out. We do not need any electronics today, laptops, phones, AirPods, all that stuff. Get them put away for me. All right, so on Wednesday, we were discussing 2x2 systems is what we started out with in this warm-up. And we said that when you have a system of equations, the solution, when we hear that word solution, we're looking for the point of intersection. Where do those lines cross each other? Okay, and so we did the warm-up, we solved by graphing, and we looked for the point where they intersect each other. Okay, and then we skipped over this. We're going to come back to this today. Okay, and we just practiced setting up systems for real world scenarios. Okay, application problems. Yeah. So for the 2x2s, we identified our two variables, x and y, and we came up with two equations for the information given to us. Okay. And we did 3 of those for the 2x2s. And then we flipped over to the next page and we said, okay, what if you have a 3x3, meaning there's 3 variables and 3 equations? So again, we're just practicing setting up the equations. And so we went through and we identified our 3 variables and wrote our 3 equations for these 3 problems. Okay, yesterday you had a Delta Math assignment practicing what we had talked about so far Tuesday and Wednesday in our notes. It was a little bit of inequalities and then practice with setting up systems. And it was mostly 2x2 practice in the Delta Math. Okay, so now what we're going to do today, we're going to go back to what we had skipped and refresh on these other methods for solving besides graphing. We refreshed on graphing Wednesday. So now I'm going to refresh y'all's memory on substitution and elimination for a 2x2 system. Okay, this is something you did in Algebra 1. So that's why I'm saying refresh. Okay, once we refresh our memory on the substitution and elimination process for 2x2s, then we're going to move into solving 3x3s. Okay, so that's our plan for today. What's your question? Monday. All right. So the steps are listed out here for you. I am going to actually go ahead and color code those so that we can kind of follow along. So step 1, we're going to start with substitution. So I'm going to do step 1 in pink. Okay, it says solve one of the equations for x or y. Excuse me. For x or y. Isolate the variables. So we want to get one of the equations in either y equals or x equals. It doesn't matter which one, and it doesn't matter which variable. So if we look at example 1a here, looking at my x terms and y terms, sometimes there's not one that's easier, and you just got to pick one. In this case, I would say one of those variables looks like it's going to be easier to solve for. What do y'all think? Yeah, the y in the second one right here, because it's positive and there's no coefficient. So we're simply just going to have to subtract the 7x over to the other side. So step 1 here is going to be pretty simple. We're going to move the 7x by subtraction. What you do to one side, you do to the other. And we're going to be left with y equals, and then I cannot combine these. This is a variable term and a constant. So it stays negative 7x plus 22. So that was step 1. Then step 2 says, okay, once you've isolated one of your variables in one of your equations, you are then going to, oh, I changed you to purple. There we go. We are then going to substitute that resulting equation, what we got here, into the other equation for that variable. So I'm going to take negative 7x plus 22, and I'm going to replace y in the other equation. So that's right here. I'm going to make this substitution. So my step 2 here, I will have 6x minus 5, and in place of y, I'm going to have parentheses and then this equation, negative 7x plus 22, and then I have equals negative 28. So far, so good? So this is what I substituted in for y. So then step 3 says, now solve that equation after you make that substitution. Switch colors, thank you. Now seriously. So now step 3 is going to be to solve this for x, because I got rid of the y. It's all x's and constants now. So to solve this, I first need to get rid of the parentheses by distributing this negative 5. I've got to distribute it to both the negative 7x and the positive 22. So I've still got the 6x in front. What's happening with this today? There we go. So negative 5 times negative 7x would be positive 35x. And negative 5 times 22 would be negative 110. And that equals negative 28 still. Now I've got some like terms I can combine, don't I? I've got 6x and 35x. What does that become when I combine like terms? 41x. And I've still got minus 110 equals negative 28. Okay, so now I want to isolate and solve for x. So I'm going to add 110 to both sides. What I do to one side, I do to the other. 41x equals, and that comes out to 82. Okay, and then I have to get rid of the coefficient. It's being multiplied by x, so the opposite operation is to divide by 41. And I get x is 2. So that was step 3. Step 3 was a little lengthier. It took me a little bit to get that solved for. So now step 4 says, okay, substitute your answer from step 3 into either original equation to find the other variable. So I can substitute this new x value that I just found. I found out x is 2. So I can replace x with 2 in either here in this equation or here in this equation, or in step 1, didn't I already solve for y? I got this in y equals, didn't I? So I could just replace the x there, and it's already set up to equal y. So that's actually what I'm going to choose to do. You can do it in the originals, but in this case, I've already solved for y, so I'm going to choose to plug it in there. So step 4, coming back over here. And I'm going to replace x with 2. Oh my. Now I need to solve that so I know what y is. So that's negative 14 plus 22. So I get 8. Bless you. So that's the substitution I made right there. I replaced x with 2, since that's what I found in step 3. That process seems somewhat familiar now that we've gone through it. I know it's been a while since you had Algebra 1, but these are basic algebra skills, is solving for different variables and making substitutions, okay? If you don't remember it, come back and look. I've got the steps all written out here. Just follow this pattern. Follow those steps. Okay, so We said that a solution is the point of intersection. So if I found my x and found my y here, how could I write this as a solution? I'm going to write it as an ordered pair because it represents a point on my graph where those lines intersect. So technically, I could graph both of these equations, and that's where they would cross at 2, 8. If you wanted to check this by graphing or solve it by graphing, you could do that. But what would you have to have done first, the way that these equations are given to you? Can you graph these in this format? No. Remember the warm-up we did? What format were they already in for us? Yeah, they were already in slope-intercept. These were not in slope-intercept. So I would have to solve for y on both of these first, but then I could graph them and I could find that point where they intersect. Okay, so you could check it that way if you wanted to. Another way, if you're solving by substitution or elimination, either one, when you get your coordinate, your solution, you can always check by plugging it into the original equations up here. You'd plug 2 in for x and 8 in for y. So for instance, 6 times 2 would be 12, 5 times 8 would be 40, and 12 minus 40 is indeed negative 28. So it checks out. And you would have to do it for both. It has to make both equations true. So 7 times 2 would be 14, plus 8 would indeed be 22. So it makes both equations true, then it is a solution. Y'all feel okay about that? So that's the substitution method. Okay, now we're going to go over the elimination method, which the steps are written out there for you again. Sophia, would you mind closing that door for me since they're working out in the hall out there? It's getting a little noisy. Thank you. All right, so elimination, here are your steps. It says multiply both or one equations by a number to result in a variable with the same coefficient. Add or subtract the equations to eliminate this variable. Solve for the remaining variable. And then do that last step. Step 4 is the same. You're going to substitute it back into one of the original equations to find the other variable. Okay. Step 1 does not always actually have to be done. Sometimes your equations are set up in a way that you can jump straight into step 2, adding or subtracting the equations. Okay, so when we say to multiply one or both equations by a number to result in a variable, what's a variable? The x or the y with the same coefficient. What's a coefficient? The number in front of the x or y being multiplied. So they're saying they want both of your x's to have the same coefficient or both of your y's to have the same coefficient. Okay, so that's the goal of step 1. Now we want to add or subtract those to eliminate. So we want it to be the same number, but we actually want it to be opposite positive and negative wise. Okay, so if one of the x's has an 8 in front of it, we want the other x to have a negative 8. Does that make sense? So that they eliminate. They reduce to a 0 is what that means. Now, in this first example down here, all of these equations for elimination, your equations have to be written in the same format as each other. You have to have the x's lined up, the y's lined up, and the constants lined up. And for the most part, we are going to have that as ax plus by equals c. Okay, that's how they're going to be written out. And so you'll line up your x's, your y's, and your constants. Okay, so you can see that's already set up for this example. We've got your x terms lined up, your y terms lined up, and your constants. But here, do you see one of your variables that has the same coefficient already? The y's, right? So if I were to add these two equations, 2 and negative 2, those eliminate already. I didn't have to do step 1. I didn't have to alter anything to get that elimination to happen. Okay, so I jumped straight to step 2, I'm going to add the 2 equations to eliminate the variable. So I'm adding my 2 equations to eliminate y in this case. Now, the x's, when I add those together, that'll be 8x. And then I have my equal. And then the c's, the constants, add up to 64. So now I've just got 8x equals 64. How do I solve that for x? Yeah, just divide the 8 over the coefficient. So I've got x is 8. Yes, I'm adding these, each of these columns. I'm adding the x's, adding the y's, adding the constants. Yes. Monday. Mm-hmm. All right, so now that I've done that, I didn't have to do step 1 here. I just went ahead and did step 2. Now, step 3 and 4 are the same as with substitution. Now we're going to, well, I actually already did the solve part. I guess I already did solve. I got x is 8. Now I'm going to jump to that last step, step 4, and I'm going to substitute 8 into one of the original equations to solve for y, to solve for the other variable. So in this case, it doesn't matter. I guess it might be easier the first one since the y is positive, since it's a plus the y term, but it really doesn't matter. Oh my goodness. Come on, stylus. Help me out here. So I'm going to have 3x plus 2y equals 22. So this is the equation I'm choosing to use, and I'm going to substitute 8 in for x. You didn't have to rewrite it out if you wanted to jump straight to just where you're doing the substitution. Oh my goodness. There we go. So I'm replacing x with 8 here. So then I'm going to solve this. 24 plus 2y equals 22. Why is it not writing everything? Okay, so then I subtract the 24 over. So that's -2, and I divide out the 2 coefficient. And I'm left with -1. So how would I write my solution? Very good. I would have x comma y. It's an ordered pair. If I were to have graphed these lines, that is the point where they would intersect. Okay, I could plug those back into both original equations and they would both come out true. Now, that one was a little easier than normal because it was already set up for elimination. If you look at part B here, the second example under elimination, the x's are not just going to eliminate. The y's are not just going to eliminate. So this is an example where you would have to actually do that step 1. That multiply 1, or sometimes you might have to do both, equations by a number so that you have the same coefficient for one of the variables. So I cannot turn 5 into 9 by multiplying it by something, right? Because 5 is not a factor of 9. So I can't do like times 2 and then they match. Okay, so there's no way to turn 9 into 5. So if I was trying to get the y's to eliminate, I would have to multiply both equations by something. I could multiply this equation by 5 and this equation by 9, and then they would both be 45 and eliminate, right? Do you understand what I'm saying? So I could do that. I could change both equations to get them to match. But in this case, I don't need to do that because if I look at my x's, can't I multiply this bottom one by something to match this one? Now, if I want them to eliminate, I don't want them both to be +4. I'd like this one to be -4, right? So I'm actually going to multiply this one by -4. Now, when I say multiply, come back up here and read this. Multiply the equation. You're not just multiplying that term. You have to multiply the entire equation by whatever that number is. Okay, so this would be the entire equation I'm going to put in parentheses, and I'm going to multiply it by -4. Okay, so it's going to, that -4 is going to be multiplied by everything in that equation, every term. Okay, so I'm going to come down here and write it a little bit lower. So that's going to become -4x, and then that would be -20y, and then that would equal -16. Now I'm going to rewrite the first equation right under it. I'm not changing the first one. It's 4x minus 9y equals -42. Okay, but I changed the second one so that now when I add these equations together, what happens? The 4x and the -4x eliminate. I got rid of the x. So what am I left with? What's the new equation I'm left with? -29y, because those are both negative. So when I add those together, I get -29y, and that's going to equal -58. So now how do I solve for y? Good. So divide out your coefficient. So I get +2. So now that was, actually should have changed colors in the middle there. I did the multiplying, I did the adding or subtracting, and I did the solving. So I'm already through step 3. I'm ready for step 4, which is to then make the substitution. I'm going to replace y with a 2 in one of these equations. It does not matter which one you use, but I think the second one would be easier. Do y'all agree? Okay, so I'm going to use the x plus 5y equals 4 equation, and I'm going to replace y with 2. And that becomes x plus 10 equals 4. I'm going to subtract the 10. And I get x is -6. So what is that as a solution? Very good. If I plugged those back into the original, they would both be true. If I graphed these, that's the point where they would intersect. That is the only point that would make both of those equations true. That is the only point that is on both of those lines. Are y'all following what a solution means? Okay. I'm not going to bother doing B here. When I post the completed key, if you want to go check it, you can. You could try this as some extra practice for yourself and see if you got the hang of it. But I want us to move on to 3x3s. You can, but it's going to be on Canvas too. So you could go back and do this B to practice substitution if you wanted. And then on the back, where earlier in the week we did all of the setup, you're welcome to go back and do the solving of these to practice. And again, I will post that on Canvas with the solving done so that you can check it if you would like to do that as some extra practice. Okay. But I want us to move on. So I'm going to close that, and I want you to look at the paper that you picked up today that says systems of equations 3x3. Okay. We are solving 3x3 now. So it's a little more complicated than the 2x2s. The steps are listed out here again for your reference, so you can always look back at this if you need to. Okay, we're not going to start with word problems. We've already practiced earlier in the week going from word problems to set up the equations. So we're just going to practice the actual solving process with 3x3s. So step 1, you're going to choose 2 of your 3 equations in which you can eliminate, there's a typo there, in which you can easily eliminate one of the variables. Okay, and when you do that combination, when you pick two of the equations and eliminate one of the variables, that new equation that you're left with, we're going to call equation A. Okay, so let's do step one. So looking at my equations in example A here, these two of them only have two variables, right? The first two equations only have X and Z. So in my opinion, I think those would be the easiest two to start with because the Y is already eliminated, right? So there's more than one way to go about this because you get to choose the two that you use, and you get to choose if you want to use substitution or elimination. Okay, so some people's may look slightly different than this and they could get the same answer, but I'm going to choose these two to start with. I'm going to ask y'all, do y'all want me to try to solve this one with substitution or elimination? Which of those methods did you think you preferred? Elimination? Okay, so I'm going to line these two up. I picked the first two, and I'm going to come over here for my step one, and I'm going to line those up. I have X plus Z equals 0, and I have 2X plus Z equals -4. Now, does anything eliminate, or am I going to have to change something? Now, the Z's are both 1Z, so that's good. I need one of them to be negative, right? So there's a couple of different ways to think about this. Instead of adding the equations, you could subtract, which would mean you're changing all of the bottom one to minuses instead of plus. Or if that confuses you and you just always want to add the equations, that's fine. We can multiply one of the equations by a negative to get the sign to change, right? So if I did the top equation, for instance, if I multiplied this by a -1, it just changes the sign of everything. Okay, so this is going to become -X. And this is going to become -Z. Now, 0 doesn't have a sign. -1 times 0 is still 0. But now when I go to add those two equations, these two right here, my Z's eliminate, right? So I'm left with 2X minus X is just X. And -4 plus 0 is -4. So that's actually really nice. This is quicker to finding one of your solutions than all of the others, maybe because Y was already eliminated from both of those. Okay, it's not always going to be that quick to get one of your values, but in this case it was. So I am going to call that, it said to call that new equation that you're left with equation A. Okay, I'm going to do the same color coding here. So that was step one. Now step two, eliminate the same variable from a combination of the equation you did not use. So the one we haven't used yet is that third one, and one of the ones you did. So we have to use the third one, and then we get to pick one of these to combine it with. Okay, so what do y'all want to use? The top or middle one to combine with this one? Top one. I think that would still be the easier one. So now for step two, I'm going to line those up again. Now, notice the bottom equation, I'm going to write it out first because it has all three variables. The top equation does not have a Y, so I'm just going to leave some space here, empty, and then put my plus Z equals 0. And the only reason I did that was so that everything lines up visually for me. If you feel like that blank space bothers you and you don't like having it empty, you could write 0Y because there's no Y, right? Okay, you do not have to do that, but it's an option. If you like to have it, if you don't like that blank space, put in a little placeholder. But this just allows me to line them up nicely. Now, and it says up here, I'm going to come back up here and reiterate. It says that we need to eliminate the same variable. So in the last one, we eliminated z, right? So we want to eliminate z. Is z already set up to eliminate, or am I going to have to multiply one of the equations by something? Yeah, it's already opposite. We've got plus z and minus z. It eliminates. Nice and easy. So now I'm going to add the other columns. So that's going to be 3x. That's just going to be plus y. And that's going to equal negative 12. And it says to call that one equation B. Then step 3 says, all right, you've got equation A and equation B now. Combine those. That's a system, a 2x2 system, because notice neither of them have z, right? So now it's just a 2x2 system. It's 2 equations with the same 2 variables. So I'm going to come over here and I'm going to do, it doesn't matter if it's substitution or elimination, whichever method you prefer. In this particular example, since the first one is already solved for x, I think substitution's probably the easier method here. Okay, because I can simply replace x with negative 4 because x is negative 4. So that's what I'm going to choose to do. I'm going to say, okay, if I plug in negative 4 for x, I can then solve for y. So I made this substitution. X is now negative 4. So 3 times negative 4 is negative 12. Plus y equals negative 12. Some of you see the answer without actually solving for y. Some of you need to actually move things to visualize that, and that's okay. Those of you who see it, what is y? Yeah, if we have negative 12 plus something equals negative 12, that's got to be 0 because we want it to stay negative 12. If you don't immediately see it, it's okay. Do your algebraic steps to isolate y. So add the 12 over, and you can then see, oh, negative 12 plus 12, that's 0. So now we've solved for y. So then step 4 says, all right, now you should have 2 of your variables, which we do. We have x is 4, and we have y is 0. So now I can plug both of those in to any of the original equations and solve for my third variable, the one that I had eliminated, the z. I can use any of the 3 equations. It doesn't matter which one. In this particular case, I think the first one's the easiest. Do y'all agree? Okay, so in my step 4, I'm going to pick the x plus z equals 0 equation, and all I have to substitute in is the x. There is no y to make a substitution, right? So this was pretty easy. I would add the 4 over. Some of you can see that answer before doing this step, and that's good. And I can see z must be positive 4. Okay, so I replaced x with negative 4. There was nowhere to replace y in this equation, so I didn't actually have to substitute that one in. If I had chosen to use the third equation, I would have had to plug both in, right? Okay, so how do I write my solution? Good. So this is no longer an ordered pair. It is an ordered triple. You can see this is how they want the solution, x, y, z. Now, with the 2x2 systems, we said that you could technically graph those and solve by graphing, right? Could you graph a 3x3? Do you have any idea why?
Riding up and down, it's all like middle of the origin going straight to you.
That's exactly right. Yes. So a 2x2 uses 2 variables, x and y. So you have your x-axis and your y-axis, and you're able to plot points. It's it's 2-dimensional. When we add z, a third axis, it would be an axis that's going forward and backward. Instead of left and right like x and up and down like y, it would come through the origin forward and backward. It would make it three-dimensional. And y'all don't know how to graph three-dimensional planes. You may remember in geometry talking about a plane, a flat two-dimensional surface. So instead of just a line having one direction or one dimension, a plane is two-dimensional. It has length and width. So if I were to try to graph this, I would be graphing three planes instead of three lines. And there is one point where all three planes would intersect, and that's this point, but y'all have not learned about that. So we can't solve this by graphing. You don't know how. Okay, so we have to be able to do this algebraic process using substitution and elimination steps. Okay, now you can still check this the same way we checked the others by plugging X, Y, and Z into the original equations, and all three should come out true. Okay, I'm going to try and pull up a visual for you to explain, because I know some people are more visual. So see. I have a good graphic here. I can show you what it would look like if you were to graph three planes. By three system. Okay, so this one might be a good one. So what it would look like if you were to graph a 3x3. Go away. There's a picture. Okay. So you see how there's a third, there's your X, Y axis, and then a third Z axis. Well, that is not the picture that I was just looking at. Just pull this over. I just Google searched images for 3x3 system. This is what I was trying to show you here. So you can see their planes. The three different planes intersect at one intersection of the X, the Y, and the Z variable. Okay, so it's three-dimensional. Okay, does that make sense? Okay, so we don't know, you don't know how to do that, and that's okay. You don't have to, but that's why we cannot solve 3x3s by graphing. You have to do this algebraic process, okay? Let's try the next one. Now, the next one looks a little more complicated, wouldn't you say? Two of the three equations here only had two variables, but here all three have all three variables. So this one is going to be slightly more work, but we are just going to follow the step-by-step process. So we are going to do step one. We are going to pick two of the equations, any two, to eliminate one of the variables. So looking at these three equations, is there one of the variables that looks like it's probably the easiest one to eliminate? Okay, cool. Yeah, 5x and 5x. We can do that. Now, actually, I'm going to stop you there because initially, yes, with those two, x is going to be easy to eliminate. But then remember, step two, we have to use the third equation, which has a 9x, and 9 and 3 are not going to mesh, are they? So yes, the first step, x would be easy to eliminate. But for the second step, x may not be as easy to eliminate. We're going to have to change two equations to get that to work. So let's actually look here at your z's. See how they're all like, I'm going to have to change them, but they can, this z that does no coefficient could easily change into either one of those, couldn't it? So I actually am going to do this one with using eliminating z's. Okay. I'm not saying you can't do it the other way, you can, but the second step would be harder. Okay. All right, so which two do you want to use first? I definitely want to use that middle one. Okay, y'all want to do the top or the bottom? Bottom? Okay, so I'm going to use these two equations in my step one. So I'm going to have 9x minus 4. Oh my gosh, I really wish my stylus would stop freaking out on me. Okay. So there's that middle equation, and here's the bottom equation. Now, what am I going to have to do to this top equation to get those z's to cancel out? Multiply by 4. It's already got the opposite sign. This one's plus, this one's minus, so we don't have to change any signs. We just need to get the 4 over there. So we got to multiply, but remember we have to multiply everything. So the x, the y, the z, and the constant. So that's going to become 36x minus 16y minus 4z, and that would be minus 240. Okay, so I went from here to here. That's my new equation after multiplying by 4. So now I am ready. I'm looking at these two, and the 4z and the minus 4z eliminate. So that leaves me with 41x minus 14y equals negative 287. And what do I call that? What does it say up here in step 1? When you do that, to call that equation A. Okay, in that last example, equation A was a lot simpler. Okay, but that's because it was missing one of the variables already. So this is my new equation A. Okay, and then step 2, I have to use the equation that I have not used yet, which is the first one. Okay, and then eliminate the same variable. So we want to eliminate z again. Now that 8, I could turn the -1 into a -8, or I could turn the 4 into a -8 by multiplying by -2, right? So actually either one of those would be easy enough. I guess I'll just stick with the middle one since it's an understood one. I don't know if that makes more sense to y'all. Uh-huh. Because I needed to get these, let me get another color here. I needed to get the coefficient in front of the z's to match. And right now that's an understood -1, and that's a +4. So to change that -1 into this -4 so that they eliminate, I had to multiply it by 4. Because that's what I was trying to eliminate the z's. So I determined that I need to multiply that by 4. And so that in black, that line is what I got when I multiplied the 4 by that equation. Does anybody have a preference on using the middle or the bottom equation with the top one? No? Okay, then I'll just use those two. So I've got 9x minus 4y plus, or excuse me, minus z equals -60. I'm using that same equation that I used over here, but now I have to use the one I haven't used yet, which is 5x minus 3y plus 8z equals -59. So here, to get my z's so that they will eliminate, I need to turn this 1 into an 8. So I'm going to multiply this whole equation by 8. and I have to distribute that 8 to all the terms. It's the same thing I did over here with the 4, but now I'm doing it with an 8. Everybody okay with that? So that is going to become 72x. Okay, and then that will be minus 32y minus 8z equals negative 480. So I went from that line to this line. That's my new equation after multiplying by 8. So now I'm ready to eliminate my z's. And so that's going to leave me with 77x minus 35y equals, and then 480 and 59 is going to be 539, and it's going to be negative. And I'm going to call that equation B, because that's what step 2 said to call it right here. It says then that's my equation B. Okay, so we will stop there for now. On the practice assignment, all I want you to do this weekend, if you look at that practice assignment, where is it? Here. I don't need you to solve any of this yet. If you want to try solving, shoot, go for it. I don't care. But I don't expect you to be able to do it yet. I want you on 2 and 3, though, on the word problems to get them set up like we were working on earlier this week. I want you to identify what the 3 variables are and write the 3 equations, but then you can stop there. You do not have to solve yet. Okay, so just get those 3 set up. Y'all have a fantastic weekend. Hang on one sec. Let me stop this recording.